Learning objectives. At the end of this topic, you will be able to define the term force, explore the effects of force in our daily life, identify the changes when a force acts on an object, classify forces into contact and non-forces.
You also know that a moving object like a ball rolling on the ground slows down. Sometimes it may change its direction of motion. It is also possible that the ball may slow down and also change its direction. Did you ever wonder what makes an object to slow down or to go faster or change its direction of motion? Yes. Let us recall some of our everyday experiences. What do you do to make a football move? What do you do to make a moving ball move faster? How does a goalkeeper stop a ball? How do the fielders stop a ball hit by a batsman? A hockey player changes the direction of the moving ball with a flick of a stick. Right. In all these situations, the ball is either made to move faster or slower, or its direction of motion is changed. We often say that a force has been applied on a ball when it is kicked, pushed, thrown, or flicked. What is a force? What can it do to bodies on which it is applied? We shall seek answers to such questions in this chapter.
We know that actions like picking, opening, shutting, kicking, hitting, lifting, flicking, pushing, pulling are often used to describe certain tasks. Each of these actions usually results in some kind of change in the motion of an object. In science, a push or a pull on an object is called a force. Thus, we can say that the motion imparted to objects was due to the action of a force. Suppose a man is standing behind a stationary car. The car will not move due to his presence. Now, if the man now begins to push the car, that is, he applies a force on it, the car may begin to move in the direction of the applied force. Note that the man has to push the car to make it move. Let's view some examples. In figure A, we can view both the girls appear to push each other while the pair of girls. In figure B, we can observe both are trying to pull each other. Similarly, the cow and the man in figure C appear to pull each other. From these examples, we can infer that at least two objects must interact for a force to come into play. Thus, an interaction of one object with another object results in a force between the two objects. Let us try to learn more about forces, taking an example of tug of war. In this game, two teams pull at a rope in opposite directions. Members of both the teams try to pull the rope in their direction. Sometimes the rope simply does not move. The team that pulls harder, that is, applies a larger force, finally wins the game. Forces applied on an object in the same direction add to one another. If the two forces act in the opposite directions on an object, the net force acting on it is the difference between the two forces. So, we learn that a force could be larger or smaller than the other. The strength of a force is usually expressed by its magnitude. We also have to specify the direction in which a force acts. Also, if the direction or the magnitude of the applied forces changes, its effect also changes. Let us now find out what happens when a force acts on an object. For example, while taking a penalty kick in football, the player applies a force on the ball. Before being hit, the ball was at rest, and so its speed was 0. The applied force makes the ball move towards the goal. Suppose the goalkeeper dives or jumps up to save the goal. By his action, the goalkeeper tries to apply a force on the moving ball. The force applied by him can stop or deflect the ball, saving a goal being scored. If the goalkeeper succeeds in stopping the ball, its speed decreases to 0. These observations suggest that a force applied on an object may change its speed. If the force applied on the object is in the direction of its motion, the speed of the object increases. If the force is applied in the direction opposite to the direction of motion, then it results in a decrease in the speed of the object. Let us find out whether application of a force can only change the speed of an object. Let us consider some more examples. In a game of volleyball, players often push the moving ball to their teammates to make a winning move. Sometimes the ball is returned to the other side of the court by pushing or smashing it. In cricket, a batsman plays his or her shot by applying a force on the ball with the bat. In all these examples, the speed and the direction of the moving ball change due to the application of force. A change in either the speed of an object or its direction of motion, or both, is described as a change in its state of motion. Thus, a force may bring a change in the state of motion of an object. Many a times, application of force does not result in a change in the state of motion. For example, a heavy box may not move at all, even if you apply the maximum force that you can exert. Again, no effective force is observed when you try to push a wall. Let us now perform some simple experiments and note observations. Applying force on an inflated balloon by pressing it between your palms. Pressing a rubber ball placed on a table. In all these examples, we can observe that the application of force on an object may change its shape. Having performed this activity, we can realize that a force may make an object move from rest, may change the speed of an object if it is moving, may change the direction of motion of an object, may bring about a change in the shape of an object, or may cause some or all of these effects. While a force may cause one or more of these effects, it is important to remember that none of these actions can take place without the action of a force. Thus, an object cannot move by itself. It cannot change speed by itself. It cannot change direction by itself. And its shape cannot change by itself. Generally, to apply a force on an object, the body has to be in contact with the object. The contact may also be with the help of a stick or a piece of rope. When we push an object like a school bag or lift a bucket of water, the force is caused by the action of muscles in our body. The force resulting due to the action of muscles is known as the muscular force. Animals also make use of muscular force to carry out their physical activities and other tasks. Animals like bullocks, horses, donkeys, and camels are used to perform various tasks for us. In performing these tasks, they use muscular force. Since muscular force can be applied only when it is in contact with an object, it is also called a contact force. Let us know about other types of contact forces. A ball rolling along the ground gradually slows down and finally comes to rest. When we stop pedaling a bicycle, it gradually slows down and finally comes to a stop. A car or a scooter also comes to rest once its engine is switched off. Similarly, a boat comes to rest if we stop rowing it. In all these situations, no force appears to be acting on the objects, yet their speed gradually decreases and they come to rest after some time. The forces responsible for changing the state of motion of objects in all these examples is the force of friction. It is the force of friction between the surface of the ball and the ground that brings the moving ball to rest. Similarly, friction between water and the boat brings it to a stop once you stop rowing. The force of friction always acts on all the moving objects, and its direction is always opposite to the direction of motion. Let us now find out about magnetic force. We know that like poles of two magnets repel each other and unlike poles attract each other. Attraction or repulsion between objects can also be seen as another form of pull or push. A magnet can exert a force on another magnet without being in contact with it. The force exerted by a magnet is an example of a non-contact force. Similarly, the force exerted by a magnet on a piece of iron is also a non-contact force. A straw is said to have acquired electrostatic charge after it has been rubbed with a sheet of paper. Such a straw is an example of a charged body. The force exerted by a charged body on another charged or uncharged body is known as electrostatic force. This force comes into play even when the bodies are not in contact. The electrostatic force, therefore, is another example of a non-contact force. Objects or things fall towards the earth because it pulls them. This force is called the force of gravity or just gravity. This is an attractive force. The force of gravity acts on all objects. The force of gravity acts on all of us all the time without our being aware of it. Water begins to flow towards the ground as soon as we open a tap. Water in rivers flows downwards due to the force of gravity. Let's summarize the topic. Actions usually result in some kind of change in the motion of an object. An interaction of an object with another object results in a force between the two objects. A force may bring a change in the state of motion of an object. An object's shape can be changed by the application of force on it.